Hello and welcome to Ms. Ma's Advanced Functions class. This is 5.4, Solving Irrational Equations. So we're going to use two methods to solve rational equations. We basically just want to find x, right? The first method that we're going to use is to just multiply by the LCD. Of course, LCD just stands for lowest common denominator. And so we just have to multiply everything by it so that we can cancel, and then we'll get the answer. So for example, x minus 2 over x minus 3 equals 0. We're going to multiply everything by x minus 3, so just multiply both sides by x minus 3. You can see that here it cancels, and here it becomes 0, so we get x minus 2 is equal to 0. And then we get x equals 2, and that is our answer. The only thing is we have to worry about our restriction, so we'll just write x is not equal to 3. This is our restriction whenever the denominator is equal to 0. That's what we have to worry about, so we'll just write our restrictions in. For the next one, I'm going to show you both methods, and it's going to be a little bit more complicated, and you're going to ask yourself, why would I ever want to do method number 2? It's actually kind of complicated, or not complicated, but longer, definitely more writing, and it looks a lot like method number 1. There is a really good reason, so just bear with me, okay? So I'm going to use method number 1 again, which is going to be to multiply by the denominator. So basically we're just cross-multiplying here. So we get x plus 3 over x minus 4. I'm just rewriting the question. X minus 1 over x plus 2. When we cross-multiply, we're going to get x plus 2 times x plus 3 equals x minus 1 times x minus 4. And then we'll just multiply this out. 5x plus 6 is equal to x squared minus 5x plus 4. And move everything over to one side. You can see that the x squareds cancel, and we're solving for x, so 10x equals negative 2 and x equals negative 1 over 5. So that is my solution using method number 1. Method 2 is really similar. It's going to look almost exactly the same. So again, I'm just going to copy this in. X plus 3 over x minus 4 equals x minus 1 times x over x plus 2. And so I'm just going to use the LCD again. In this case, the LCD is x minus 4 times x plus 2. So I'm going to multiply x plus 2 to the top and the bottom here. So I'll get x plus 2 times x plus 3 over x plus 2 times x minus 4. And over here I'm missing an x minus 4, so I'm going to multiply that in the top and the bottom. So I get x minus 1 times x minus 4, over x plus 2 times x minus 4. And so you can see I have the same denominator now. So I'm going to multiply that out. I get x squared plus 5x plus 6 over x plus 2 times x minus 4 is equal to x squared minus 5x plus 4 over x plus 2 times x minus 4. And you can see that these are really parallel. I've got exactly the same thing going on in this line right here. And then I'm going to move everything over just like I did with this one. So I get 10x plus 2 over x plus 2 times x minus 4 is equal to 0. Now this whole thing can't be 0 unless the numerator is 0, so I'm going to set the numerator equal to 0. And just state my restrictions, x not equal to negative 2 or 4. And then I can solve that in the same way as I did the other one, and I get x equals negative 1 over 5, just like I did before. And you can see method number 1 and method number 2 are really, really similar, except there's much more writing in method number 2. But don't worry, there is a good reason. You'll just have to wait until tomorrow to find that out. So let's do this word problem together. When they work together, Gaddy and Alice can deliver flyers to all homes in their neighborhood in 42 minutes. When Alice works alone, she can finish the deliveries in 13 minutes less time than Gaddy can when he works alone. How long does it take Gaddy to deliver the flyers by himself? Now before we tackle this problem, I would like to talk about it a little bit. So if you think about how this kind of thing works, let's say that Gaddy's time is 15 minutes. And that means that Alice's time, which is 13 minutes less, is 2 minutes. If they working together, it should not take them 17 minutes. Does that make sense? Because Gaddy plus Alice should be shorter, so it should not be 17 minutes. It should be shorter than Gaddy's time, right? Because she's helping him out, so it goes faster than his time or their time combined. So we can't do it this way. We can't just add the two times together. That's not going to work for us. And another thing that I want to point out is that if Gaddy's time is 15 minutes, that means that in 1 minute, Gaddy would finish 1/15 of the neighborhood. Does that make sense? And so this is actually a really important little theme to remember, because this is how we're going to set up our whole question. So let me just erase that. Let's go back up. First of all, let's define the variables. So let x be Gaddy's time, and that means that x minus 13 is Alice's time, because she's 13 minutes faster. So we can't just add x and x minus 13 and let that be equal to 42, because it should be, 42 should be less than one of their times at least. So what we're going to do is we're going to say, okay, in 1 minute's time, how much of the neighborhood is finished? Well, if it's just Gaddy alone, then he will have finished 1 over x of the neighborhood, because he finishes the whole thing in x minutes, so in 1 minute he finishes 1 over x of the neighborhood, right? For Alice, in 1 minute's time, she has accomplished 1 over x minus 13 of the neighborhood. But if they're working together, since they can accomplish the whole thing in 42 minutes, in 1 minute they should have finished 1/42 of the neighborhood. Or in other words, when these two are working together, when he does his part and she does her part, that will add up to 1/42 of the neighborhood. So let's say he's working here and he finishes this much and she finishes this much in 1 minute, then these two together must be 1 over 42. So we can write that out as an equation. It's 1 over x plus 1 over x minus 13 is equal to 1 over 42. That's the amount of neighborhood done in 1 minute on either side. Okay? So this is the hardest part about solving this question, because the setup is always the most difficult part. Once we've got that, we can just multiply by the LCD. The LCD in this case is 42x times x minus 13, since they have nothing in common. So we're going to multiply everything by the LCD. So 42x times x minus 13 over x. And you can actually skip this step. I just want to show it in case people get confused. Over x minus 13 equals 42x times x minus 13 over 42. And then we're going to cancel. So here I can cancel x minus 13, here I can cancel that 42, and here I can cancel x. So I get 42 times x minus 13 plus 42x equals x times x minus 13. So we will expand that. This becomes 42x minus 46 plus 42x equals x squared minus 13x, and we just move it all over. We'll get x squared minus 97x plus 546. So these numbers are really big, so I use the quadratic formula. So x equals negative b plus minus square root b squared minus 4ac over 2a. You should always show the formula when you use it. So we get 97 plus minus the square root of 97 squared minus 4 times 546 over 2. This actually ends up being 85, so we get 97 plus minus 85 over 2. So our answer is x equals 91, or 6. Now, one of these is actually inadmissible, so you do have to double check to see if you can use both of them. 6 is inadmissible, and I'll tell you why. It's actually because of Alice, because Alice is 13 minutes faster than Gaddy. So if he can do it in 6 minutes, she would have to do it in negative 7 minutes, and that doesn't make any sense at all. So Gaddy must do it in 91 minutes. So the answer, and because it's a word problem, we should answer it as a word solution. I'm just going to double check to see that I'm doing the right thing. How long does it take Gaddy to deliver the flyers by himself? X is Gaddy's time, and that's what we have found. So just double check that. Gaddy's time is 91 minutes, and that's it. Put a little victory dance around it, and we're done. Okay, so we've got one more question. You can try setting up on your own, or you can follow along with me. So pause the video if you would like to do this on your own. Okay, so Athanasia bought a case of concert t-shirts for $450. She kept 2 t-shirts for herself and sold the rest for $560, making a profit of $10 on each t-shirt. How many t-shirts were in the case? So again, the first thing that we want to do is make a let statement. So we'll say let X be the number of t-shirts. Now the key to this question is to do it per unit. Per unit. So we're going to have to do, remember, $10 is the profit per t-shirt. So $10 is how much she makes, and she sold them, she sold each of them for $560 over X minus 2, because that's how much she made total, and X minus 2 is the number of t-shirts she sold. And she bought them for $450 over X. So she bought the whole thing for $450, and she had X t-shirts in there. So that is how much she paid per shirt. So this is the revenue per shirt minus the cost per shirt, which gives us the profit per shirt. Okay? So we're doing everything per shirt, which sounds funny when I said it that many times. It sounds weird. Okay. So now that I have my equation set up, I can solve it. Again, I'm just going to be multiplying by the LCD. So 10x times x minus 2 equals 560 times x minus 450 times x minus 2. If you're not sure how I did that, you can pause the video and try it on your own and make sure that you know how to do it. So I get 10x squared minus 20x equals 560x minus 450x plus 900. Don't forget to change the sign because I'm carrying that negative into both using distributive property. So 0 equals 10x squared minus 130x minus 900, and I can actually common factor out a 10 and just cancel it out. So I get 0 equals x squared minus 13x minus 90. You can use Pythagorean theorem or you can factor. This actually ends up being x minus 18 times x plus 5. So we know we have x equals 18 or x equals negative 5 as our solution. Of course we can't have negative t-shirts, so this is inadmissible. So we know that Athanasia had 18 t-shirts total. So we'll just answer the question, how many t-shirts were in the case? There were 18 t-shirts in the case. And put a little victory dance around it, and we're done. So basically what we learned is that we can multiply by the LCD to solve rational expressions, and if we're doing these word problems, we do want to set them up so that we have x's in the bottom and we have to solve the rational expression. Okay, so thanks for watching. Bring me any questions you have into class, and I will see you soon.